Good morning, everyone. Today we will start the next part of the rotational dynamics. In this, first we will study the kinetics of circular motion. Kinetics of circular motion. Okay, you can take down the notes while watching this video and remember the formulae, dimension, etc. Okay, kinetics of circular motion. In this section, we will study three topics. One is the angular displacement, second one is the angular velocity, and third one is the angular acceleration. First, we will see what is the meaning of this radius vector. Radius vector. Okay, in circle there are two important parts. One is the center and second one is the circumference. The vector which represents the position of particle, the vector which represents position of particle on the circumference of circle from center of the circle is called as the radius vector. So this is the radius vector. It is denoted by r bar. The vector, the definition of radius vector, the vector which represents the position of particle on the circumference from center of the circle is called as the radius vector. Okay, this is vector quantity. Its magnitude remains constant but direction changes continuously. Okay, then afterward, then there is angular displacement. Angular displacement, it is denoted by letter theta, and small angular displacement is denoted by d theta or delta theta. Small angular displacement is denoted by delta theta or d theta. Okay, so now we'll study the definition of this angular displacement. Suppose initially the particle is at position A, and in time interval delta t, it covers arc length of delta s, and reaches the point B, then angle covered or angular displacement is the delta theta. Angular displacement is the delta theta. The formula for this angular displacement delta theta or angle, it is equal to arc length upon radius denoted by delta theta equal to delta s divided by r, or you can write delta s equal to r into delta theta. This angular displacement, it is a interesting fact. It is vector as well as scalar. When it is vector, when this angular displacement delta theta is small or instantaneous. When angular displacement is small or instantaneous, then it is vector quantity, and when angle is large, then it is the scalar quantity. Angle is large, then it is the scalar quantity. The definition for angular displacement: the angle made by radius vector, at the center of the circle. Angle made by radius vector at the center of the circle is called as the angular displacement. Okay, the definition of angular displacement: angle made by radius vector at the center of circle is called as the angular displacement. It is scalar as well as vector. When it is scalar, it is large, and vector small or instantaneous. Formula: delta theta equal to delta s upon r. Its unit, SI unit is radian, and dimension, it is dimensionless quantity. You have to remember this angular displacement or angle, it is the dimensionless quantity. Okay, when we consider it as vector, then it has magnitude as well as direction. So now we'll see how to get the direction of this angular displacement. The direction of angular displacement is given by right hand thumb rule. Okay, consider the circle in the horizontal plane. Okay, horizontal plane and the vertical plane. This circle initially it is in the horizontal plane. Okay, this is the circle is in the horizontal plane and axis is in the vertical plane. Axis is in the vertical plane. So we will see right hand thumb rule. In right hand thumb rule there are two important parts. First part is the curl fingers. First one is the curl finger and second is the stretch thumb. Curl fingers and the stretch thumb. Okay, in case of curl finger you have to take the direction from this base to tip. In case of curl finger you have to take the direction from base to tip and stretch thumb. Okay, the right hand thumb rule statement. Imagine the axis of rotation. Imagine the axis of rotation is held in right hand. If curl finger gives direction of rotation, then stretch thumb gives the direction of angular displacement. Okay, getting the point? When the curl finger gives direction of rotation, then stretch thumb gives the direction of angular displacement. In this case, if direction of rotation is anti-clockwise, okay, here direction of rotation it is anti-clockwise, then direction of angular displacement is in the upward direction. Direction of angular displacement is in the upward direction when the direction of rotation is anti-clockwise. And when the direction of rotation is clockwise, in this way, then thumb points in the downward direction. Therefore, this angular displacement it is also in the downward direction. So getting the point, this angular displacement, small angular displacement is the vector quantity. Curl finger gives direction of rotation and stretch thumb gives direction of the angular displacement. Okay, this is the angular displacement. For entrance point of view, in complete one rotation, the angle covered in case of radian it is 2 pi radian, which is equal to 360 degree. So conversion of this 1 radian equal to 360 divided by 2 pi, it comes 1 radian equal to 57.3 degree. You have to remember this important relation which comes frequently in entrance exam. 1 radian equal to 57.3 degree. Okay, this concludes the topic of angular displacement. In angular displacement we have studied its definition, formula, scalar vector, dimension, direction, etc. Right hand thumb rule, conversion factors. Okay, now we'll see the next part, angular velocity. Angular velocity. Angular velocity, it is denoted by this letter omega. It is not W, it is the omega. Angular velocity omega. In simple velocity, it is equal to displacement upon time. Displacement upon time. Just you have to write here angular velocity equal to angular displacement divided by time. So you can say the definition on the same line. The rate of change of angular displacement, with respect to time is called as the angular velocity. The rate of change of angular displacement with respect to time is called as angular velocity. It is denoted by letter omega, will be equal to d theta divided by dt, or just you can write omega equal to theta divided by t, or you can write in terms of limit also. This omega equal to limit delta t tends to 0, delta theta divided by delta t. Okay, then another formula, if angle covered is 2 pi and in total time period of capital T, so the formula omega equal to 2 pi by t, and another formula put here, frequency 1 of n equal to 1 upon t, so omega equal to 2 pi n. These are the different formulas for this angular velocity. Okay, omega equal to 2 pi n, omega equal to 2 pi by t, and its SI unit, it is radian per second. SI unit is radian per second. Okay, SI unit is radian per second. Dimension, radian is dimensionless. L0, m0, t minus 1. This is the dimension of this angular velocity. Angular velocity is always vector quantity, although it is small or large. Whether it is small or large, angular velocity, it is the vector quantity. So again, the direction of angular velocity, it is also given by, direction is given by right hand thumb rule, and the direction of angular velocity is same as angular displacement. So if particle is rotating in anti-clockwise direction, then the angular velocity is denoted by thumb. Stretched thumb gives angular velocity omega, it is in the upward direction. Curl finger gives direction of rotation. If the direction of rotation is clockwise, then angular velocity, it is pointing in the downward direction. So the direction of angular displacement and angular velocity, it is same. When it is anti-clockwise, it is upward. When it is clockwise, it is in the downward direction. This is angular velocity. Okay, again we will revise this angular velocity. Definition of angular velocity: the rate of change of angular displacement with respect to time. The rate of change of angular displacement with respect to time is called as angular velocity. Formula: omega equal to d theta by dt, omega equal to theta by t in terms of limit, then omega equal to 2 pi by t, frequency omega equal to 2 pi n. SI unit is radian per second, dimension L0, m0, t minus 1. Direction is given by the right hand thumb rule. Okay, now we'll see for entrance point of view, you have to know the angular velocities of minute hand, second hand, hour hand and earth. These are the important parameters. Here I will make the chart. First is the second hand, minute hand, third one is hour hand, and fourth is the earth. Okay, this second hand time period, it completes one rotation in 60 seconds. It is 60 second time period in seconds, 60 second. Angle covered, it is 2 pi. Angle covered is 2 pi, and this angular velocity formula is theta by t. So it comes 2 pi by 60, which will be equal to pi by 30 radian per second. Pi by 30 radian per second. For this further calculation, you have to do by using the log tables. Okay, this will be for your homework. You have to make the calculation by using log tables. Okay, this is for the second hand. Similarly for minute hand. Minute hand completes one rotation. Minute hand completes one rotation in 1 hour. It completes one rotation in the 1 hour. So time period will be equal to 1 hour equal to 3600 second. 3600 second. Angle remains the same. So this omega will be equal to 2 pi divided by 3600, which will be equal to pi divided by 1800 radian per second. Okay, then hour hand. Hour hand completes it one rotation in 12 hours. Okay, it completes one rotation in 12 hours. 12 hour equal to 12 into 3600 second, which will be equal to 43200 second. So this angular velocity comes as 2 pi divided by 43200 radian per second. Okay, then important is the earth. It is required in most of the chapters. Angular velocity of the earth, important value you have to remember after calculation. Earth completes in one rotation in 24 hours. Time period 24 hours, which will equal to 24 into 3600 second. It comes as 86400 second. Angle theta is 2 pi. Theta is 2 pi. Then this omega 2 pi by 86400. Okay, 86400 radian per second. Then it comes as pi by 43200 radian per second. You have to make the calculation and get the value in terms of power of 10. It is important value, the angular velocity of the earth. Okay, this is for your problem purpose and also for entrance exam. Okay, in angular velocity we have studied its definition, angular velocity, then its formula, unit, dimension and its values. Okay, now we'll see the angular acceleration, the last